morning to all. This is Dr. MD Yusuf Mulge, Professor in CSM Department of Marri Laxman Reddy Institute of Technology and Management. So, today I will deliver a lecture on software engineering. It is uh, one of the very important subject for computer science and engineering because after completion of the degree the students are going to join a software development company. So, if they want to develop the software, the knowledge of software engineering is necessary. The introduction to software engineering here, the term software engineering refers to software and engineering. That means it is consisting of two words, software and then engineering. Here, software is collection of integrated programs. So then engineering is nothing but the use of science and maths to solve the problems. So that is the software engineering. Then next is software is classified into two types. One is generic and second is the custom. The generic software is developed for the general use. For example, Word, Excel, PowerPoint, and so on for general purposes. Then custom software is developed for a fixed customers. As per the need of the customer, the custom software is developed. Now, for example, custom e-commerce websites, custom applications, and so many applications that are developed for a particular uh, group of persons. Now, engineering is the application, as I told you, engineering is the application of science and maths to solve the problems. Or it is the process of designing a software for a group of people, or you can say even a company. Now, I will just shift on to the software testing. Now, once the software is developed, it is required to test whether it is providing the necessary services or not. That is, the customer requirements, is it satisfying, is it fulfilling? That for that purpose, we need to test the software whether it is fulfilling all the needs of the customer or not. So now here the objectives of the testing are that is to find out the errors, because if errors are there, then the software may not provide the required output. Now, a successful test is one which uncovers all the errors present in the software. The major testing objective is to design, test, and uncover the errors present into the software. The principal goal of the testing is to ensure that the users are not negatively affected. That is, whatever are the needs of the user, the needs are fulfilled. Now, here, bugs or you can say errors in the software are providing the incorrect results. Therefore, here we need to remove all the errors so that the software provides the required output to the customer. Now, here the types of the bugs are the many kinds of bugs are there, but the bugs that are divided into based upon the impact levels. Now, whether it is the bug or error is having a high impact onto the software or the low impact on the software, and a critical bug is the one in which you cannot use the software at all. That means it will provide the unnecessary output, that is wrong output. So therefore, no, if low impact bugs are there that do not cause serious problems to the software, because the error is having low impact. Then comes high impact bug. The high impact bugs are having more impact onto the software. So even then the software can be used. That is, whether the bug is having low impact or the high impact, then also we can use that software. Then there is one type of the software which is called as the critical bug. The critical bug affects the core functionality of the software. So that means now the software cannot be used at all. So it will provide wrong output. So therefore, when critical bug is there, the software cannot be used at all. So why testing is important? Now here the software testing is a critical process. The purpose of the testing is to maintain the software quality, validates requirements, mitigates risks, and enhances user satisfaction. Now, so these are the four properties of providing the testing. That is, these are the 4 points where we need to test the software that has been developed. Now, the some of the reasons why testing is important are as follows. So that is, now one is the identify mistakes. Okay. Now, after identifying, then we have to fix that bug. So this is the main purpose of testing the software. Now here, some of the reasons for testing is the quality control. Now, if there is no bug, then the quality of the software can be maintained. So if quality is maintained, that means it will provide the necessary output to the customer. Now, then next point is ensure software is ready. One more reason is ensure software is ready. So once all the bugs are removed, then it will provide a software which can be delivered to the customer. Then avoid unnecessary costs. If bugs are there, then we have to go back and then we have to remove all the bugs. So this requires lot of effort, time, and cost. So because of these points, quality control, ensure software is ready, avoid unnecessary cost. Because of these are the points, these are the reasons for testing the software. Then here one more reason for testing the software is that it improves customer satisfaction. So whatever initially we had told, then all those needs of the customers are satisfied. If customer needs are satisfied, then that improves the customer satisfaction. Definitely, if whatever customer wants, if the software provides, then the customer will be very, very satisfied. Now, here the testing validates the code of the developer. That means whatever the developer has provided the codes, so that provides the correctness of the code, the reliable and maintainable. So that improves the customer satisfaction. Now, software testing is done by a testing team. Special team is there. Their work is to test the software that is developed. Now, then all the associated tests are carried out by as approved by the higher authorities. You can say software engineer or software manager, whoever approves the test process. That process is followed to test the software. Now, testing strategies. So what are the strategies that are used for testing? Now here the testing strategy provides the roadmap to the roadmap for the testing. So the steps to be conducted as part of the testing it will provide. Now, when these steps are planned and followed, then it decides how much effort, time, resources are required for that software testing. Now, testing strategy must be incorporated as per the planning of the higher authorities like software manager, software engineer. As per their planning only, we have to test the software. Now, a strategy for software testing is developed, as I told you, by the higher authorities. Now, software is tested to uncover the errors present in the software. As errors are uncovered, they must be diagnosed and should be corrected. Okay, this process of correcting errors is called as debugging. That means removal of the errors is called as debugging. So once the software is debugged, then it will provide the necessary output, or the expected output it will provide. Now, software testing life cycle. Okay, what life cycle is followed in software testing? Software testing life cycle is a sequence of uh, methods, sequence of processes that are followed to test the software. Now, this once the sequence of methods are followed, it ensures the quality of the software. Now, the STL, that is software testing life cycle, uh, both it will provide both verification and validation activities to the software. Now, following are the six major phases in every software testing. The phases are the requirement analysis, test planning, test case development, test environment setup, test execution, test cycle closure. So these are the six steps of STLC, software testing life cycle. Now, one by one, every step is followed. So these are that here requirement analysis, test planning, test case development, environment setup, test execution, test cycle closure. Lastly, once the testing is over, all the bugs are removed, then the test cycle will be closed. Test planning. Now, as per the senior quality assessment manager, the test planning determines the test plan strategy. Now, here it also develops the efforts or cost estimates. How much cost is required, how much the effort is required for developing that software, that is provided by the phase test planning. Now, moreover, the resources, test environment, test limitations, and the testing schedules are also determined here in test planning. Now, test case development. Next phase is the test case development. Here, the test case development is the creation and the verification of network of test cases. Okay, what is required in the test cases? All that is finalized. Then it also determines the test scripts. Then next, the third phase is test case development. The test case development activities are create test cases, automation scripts, then review and baseline test cases and scripts, create test data. So these are the activities that are followed in test case development. Then test environment setup. Now, for testing every software, it needs the platform required to test that software. So therefore here we need to develop, we need to provide the test environment. So therefore once the test environment is provided, then the software can be tested. Now, it is one of the critical aspects. So, this test environment setup can be developed in parallel with the test case development, the previous phase, test case development. Then, test team cannot be is not involved in the uh, process of testing, because no, the test team come across at the end when the software is completely developed. Then that it is the function of the testing team to test that software. Now, the test team is required to do readiness checkup. That means the software readiness, it will test. So the software will be ready when the complete code for that software is developed. So therefore, so it will test the readiness, or it will provide the readiness of the software. Test execution phase. The test execution phase is carried out by the testing team. Now here we have to run the software, we have to run the program, and then check whether it is functioning or it is providing the required output or not. Now, the process here, the test case execution, the process consists of test scripts execution, test script maintenance, and bug reporting. Now, if bugs are present, then the software is handed over back to the developer by the testing team, and then those bugs are required to be removed. So, therefore, here the testing team will help the developer to uncover all the errors. Test cycle closure. Now, once code is ready, complete code is developed, then it shows the completion of the software. Then test completion reporting will be done to the higher authorities, and then the testing team members meet, discuss, analyze the testing artifacts to identify the strategies that are required to be implemented for the future, taking lessons from the current test. Test cycle closure activities here. The activities of the test cycle closure are: it evaluates cycle completion, then based upon the cycle completion, based upon the time, test coverage, cost, software, and then critical business objectives, and then quality. Based upon these 6 points, the if these 6 points are followed, if these 6 points are fulfilled, then only we can close the activity of the software development. Now, after the test, that is in the test cycle closure, so we have to prepare test metrics based on the above parameters, then document the learning out of the project. So that means once the software is ready and it provides the necessary output, then we have to prepare the document. So which points, how that software can be used. Then qualitative and quantitative reporting of the software. Then test result analysis is done to find out the defects into the software. Test strategies for conventional softwares. Here there are few strategies that are used for the conventional softwares. So of course there are many methods, but whatever are the effective methods, those are used for testing the software. Because a buggy software, that is in which errors are present, so it will disappoint the stakeholders and the customer. So therefore here all the errors are required to be removed. That means the software should be debugged. So all the errors should be removed. Then it will provide the satisfaction to the customer and the stakeholders. All the other, that is now here in case of the testing can be done at once. That is, the whole software can be tested at once, or it can be tested on daily basis. Once a part of the software is developed, then that should be checked. So therefore, on daily basis also we can test the software. So this will be very effective. The daily basis testing is very, very effective, because so the code that we are testing on daily basis is limited. It's not wide. So it is limited. Therefore, because of the limited code, the testing becomes easy. Whereas if we test the entire software at once, then it may not provide the necessary errors. It may not point out the necessary errors. So because the code is very big, so therefore the testing on daily basis is very, very effective compared to the entire software testing. Types of test strategies. Here, following are the types of test strategies. One is the unit testing, second is the integration testing, third is validation testing, and fourth is system testing. So these are the four methods for testing the software, conventional software you can say. Now, in case of the unit testing, that means a big software is divided into number of units, and then each unit after development is tested. So that is, so if it is the smallest part of the software, because the big software is divided into small units, and then each unit after coding is tested separately. Now here it is nothing but the execution of a single unit. The developers are responsible for performing the unit testing, because here testing team, when it will come across, when it is involved, when the total software is developed, when the entire code is developed, then only the testing team will be involved in the testing. Whereas in unit testing, the developer develops one unit, and then immediately he will test that unit. So therefore here the developer himself or herself is responsible for unit testing. Now here the module that is developed, that means unit is also called as a module. A big software is divided into a number of units or number of modules. Now it will ensure, that is, the unit testing ensures that the information flows perfectly from input to the output. Now here whatever are the data structures we have used here, the integrity of the data is ensured in case of the unit testing. Now in case of unit testing, it will also check the boundary conditions. That is, so the input to nearer input to is provided, and then so whether it will provide the output or not, that is ensured. So that is, the boundary conditions are checked. Now in case of the unit testing also, all the paths of the data flow are checked or tested at least once. Now the test case should be one that should uncover the errors present into the software. Now unit test is an adjunct to the coding step, because once the unit is coded, then immediately after the unit is coded, then testing carried out. Therefore we can say that unit testing is adjunct to the coding step. Now a review of design information provides guidance for establishing test cases. So guidance for the test cases is required. Then after unit testing, the integration testing. In case of the integration testing, so that is all the units of that software are joined together, integrated together. And then that means if each unit is working perfectly after integration, the entire software will work as per the need of the customer. So therefore here after unit testing, the integration testing is to be carried out. So that means if the software is, let us say the software is divided into 5 units, then that is each unit is developed separately and tested. Then when all the units are providing the required output, then after integration also they will provide the required output because each unit is working perfectly. The entire program should be tested as a whole, but as the code is very high, so the errors that are provided are pointed out by the entire program testing will be will not be able to point out. Now here it is not easy to point out the or and isolate the errors. Now now after each unit is developed, then the interface is also required to be tested. When individual components are already working, then as I told you, the after integration, the entire software should work perfectly. But there are few reasons. So even if all the units are working perfectly, the integrated software may not provide the required output. There are reasons for this. Okay, it's obvious that once all the units are tested separately and integrated, then after integration also the software should provide the required output. But there are reasons sometimes the software may not provide even if the units are working perfectly. So the reasons for this are data loss, increased impression error, then the purpose of modules may not be fulfilled, modules may badly affect the integration. Now here, due to data loss, the integrated software may not provide the required output. Then the increased impression error means the customer needs some output, some results, but there may be difference between the expected output and then the software that provides the output. So that is called as the impression error. Then the each module after integration may change its functioning. So therefore, the purpose of modules may not be fulfilled. Then modules after integration may badly affect the integration. So because of these 4 reasons, the integrated software may not work. Okay, this is the figure which provides, that is integration testing methods. Now, in case of the integration testing, here one method is the incremental testing. One of the method is incremental testing, and second is the non-incremental testing, or it is also called as the Big Bang testing. Now, in case of the incremental testing, so there are a few methods. One is the top-down integration. The second is bottom-up integration. Third is sandwich testing. The fourth is regression testing. And fifth is the smoke testing. So these are the 5 incremental testing methods. Now let us see one by one. In case of the top-down integration, as the name itself implies, the testing starts at the, or you can say the integration starts at the top. That is the main program. Now then it moves down. after the main program, main module, it moves down. The modules that are subordinating the main procedure are again integrated. Now, the modules may be integrated based upon the depth first test or breadth first test. Now, so these are the two methods that are used for the integration of the software. So that is here, for example, let us say the figure M1 is the main module, then M2 subordinates, M3 also subordinates, M4 also subordinates. Then subordinate to M2 is M5 and M6. Subordinate to M5 is MH. Likewise here, considering these modules, now in case of the depth first integration, the testing starts at the M2, and then after M2 the M5 is integrated, after M5 MH. Then after that M6, then starts at the right end, that is the subordinate of M1 is M3 and then M7. First M3 is integrated, then M7 is integrated. Then one more module that is subordinating the main module M1R is M4. So this is depth first. We should move down, down, down and down. Then we should go to the next step and then again down. The next step, you can say right side again down. Like that here, depth first integration has been carried out. Now, then after depth first, so we have the breadth first. In case of the breadth first, so that is we are not going to going into deep in depth. We going to wide. We will go in now. So first M2 is integrated, then M3, then M4. Then we will move down, then M5, M6 and M7. After M7, we will move down and M8 is integrated. And then after each integration, we are going to test. The integration process is performed in 5 steps. The main control module is used as a test driver. Now that is the main program, it is used as a test driver. Then steps are stubs, STUBS, stubs are substituted for all the components. Then the second phase, second point or second step is depending on the integration approach selected, whether it is the depth first integration is selected or breadth first integration is selected. Based upon the integration approach that is selected, tests are conducted as each component is integrated. That is, first steps are used, then that step will be replaced by the actual component. Then fourth point, on completion of each set of tests, another step is replaced. Likewise, one by one, these steps are replaced by the main components. Then bottom-up integration. In case of the bottom-up integration, the integration starts at the lowest level, leaf level, and it moves upwards. So bottom-up integration strategy may be implemented with the following steps. The steps for the bottom-up integration are: low-level components are combined into clusters. So low-level components are combined into clusters, and then each cluster is having a driver, so that is used for that component. The cluster is then tested. For example, the cluster is consisting of say C1, C2, C3. Okay, so this is then having a driver, so that helps the cluster is tested. The drivers are removed and clusters are combined directly upwards to the main programs. For example, here if we see uh, the here, if you see here, the M2, M3, M4 is a cluster, then M5, M6, M7 is one more cluster, and then M8 is the third cluster. Likewise, each cluster is having a driver. Here the M1 main program M1 acts as the driver. So the driver helps in integration and then testing. After replacing all these steps by the actual components, then regression testing is carried out. Now, regression testing is the one which will check whether the output has changed or not, whether the output is stable or not. So that is tested by regression testing. So because here we are going to add each of the unit. So after adding a unit, whether the software is providing the complete output or not. So that is done by the regression. That is, and then after integration, whether the software is stable or not. So that is also checked by the regression testing. Now, the likewise here, the process continues that all these steps are replaced by the actual components, then the entire software will be ready. In bottom-up integration, the components, as I told you, component starts at the integration at the lowest level like that. Okay. Yes, the low-level components are combined into clusters. A driver is used to coordinate the test. Okay. Then third is the cluster is tested for the functioning. Then drivers are removed one by one, and the components are connected to the main component. Now then, after top down and bottom up, the next type of testing is the sandwich testing. Now the sandwich testing use the advantages of both top down and bottom up methods. So it is also called as hybrid integration. So that means sandwich testing is more advantageous compared to the top down and bottom up methods. So regression testing, that is when a new module is added to the software, then whether the output has changed or not, and whether the software is stable or not, that is checked by the regression testing. Now, and then the regression testing also checks the new data flows, because we have added a new module. After adding the new module, whether the data paths have changed or not, so that is checked by the regression testing. So that means the regression testing fulfills two conditions. One is that whether the output has changed or not, and then second is whether the data flow path has changed or not. So these are the main purposes of regression testing. Now here, if the data path changes, then it may cause problems into functioning of the software. Now here the regression testing is nothing but it is the re-execution of the program. That is when a new module is added, so we are going to re-execute the program. Therefore, it is also called as the re-execution of the software. Smoke testing. Here, the smoke testing checks one main point, that is whether the software that has been developed is stable or not. That is the main purpose of smoke testing. Now, the smoke testing also ensures the quality of the software. So here, that is, it consists of a minimal set of tests, the smoke test. Then smoke testing is also known as build verification testing. That is, we have built a software and then we are going to verify that it will provide the required output or not. So that is the smoke testing. Number one is it checks whether the software is stable or not, and then it is also the build verification testing. That is, whatever software has been built, whether all the conditions or all the requirements are fulfilled or not, or you can say the expected results it is providing or not. In simple terms, the smoke test means verifying the important features of the software. So, and also it will ensure that there are no showstoppers. That means there are no any or there is no any code which will change the functioning of the software. So that is also checked by the smoke testing. Then it will, in simple terms, the smoke testing ensures that the software is ready. Then this smoke testing also helps, that is, whether the build is having flaws or not. Now here, the errors that are mm, after after uh, supplying to the customer are called as the flaws. Before handing over the software to the customer, it's called error. So that is the should be removed by the developer. Then after handing over of the software to the customer, it's called as the flaws. So therefore, flaws takes time to remove, because we have to collect the software from the customer, and then we have to remove the errors. We have to remove the flaws. Now, so one more type of the testing is the non-incremental testing. So here we have discussed a few incremental tests. So that is the non-incremental testing methods. One is that is here the figure shows the incremental and non-incremental test procedures. So that till the regression testing, so these are the non-incremental methods. Then after the non-incremental methods, so the that is after incremental testing. Now we have to discuss about the non-incremental testing. Because here the total software is required to be tested at once. That is also called as the big bang approach. The entire software, how big it is, should be tested at once. So therefore that means the incremental procedure is for big softwares, whereas non-incremental testing is used for small size softwares where the code is limited. So that is the advantages of the big bang approach are, that means it is used for small softwares. Now, disadvantages of the big bang testing is that the testing can be done after completion of the entire coding, and the testing may not uncover interface errors. The big bang testing, the modules are critical to the system may not receive the extra testing. So that is the advantage is that the big bang approach is useful for small systems. At once the entire code can be tested. Disadvantages that the testing can commence only after the entire software has been coded, and the testing may not uncover the interface errors. Then the modules that are critical to the software may not receive the extra testing. These are the disadvantages of the big bang testing. Now comes alpha and beta testing. The alpha testing is the one which starts at the early stage of the development. So that means here the alpha testing is carried out in the organization itself. The organization which is developing the software, in that only it starts. So here the people who are involved in the alpha testing are the internal stakeholders only. That is consisting of developer, tester, and the product team. So these are the people involved in alpha testing. The purpose of the alpha testing is to identify and resolve critical bugs that are present into the software. So therefore here it is released after the alpha testing, because so internal to the organization itself the alpha testing has been carried out. If there are no errors, then the software is released. During alpha testing, here it evaluates a set of predetermined acceptance criteria. So the higher authorities, you can say the software manager, software engineer, they will place certain acceptance criteria. So those, that means in alpha testing, the acceptance criteria is followed. Here it will test the functionality, usability, performance, and stability of the software. So this is ensured by the alpha testing. Now here the purpose of the alpha testing is to identify the errors and remove them. Then again it is also checking whether the software is meeting the customer's requirements or not, whether the software is fulfilling the customer requirements or not. Then comes beta testing. Beta testing is actually performed by the users, the customer. Okay, so that means once beta testing is over, then the customer has to accept the product, because he himself, the customer himself, will be testing the software. Therefore, the beta testing is released to the limited number of users. Okay, and then those users, after testing the software, will provide the feedback to the developer. So then, depending upon the feedback, the software has to be modified, the software has to be changed, and then released to the customer. Therefore, alpha testing is done in the organization itself. So it will take long time. The alpha testing takes long time, whereas beta testing is done after the software is handed over to the customer. Therefore, the beta testing takes less time compared to the alpha testing. It's also the acceptance testing, because the customer himself or herself will check the software, and then if it provides the required output, the customer will be satisfied, and then he will accept the software that has been developed. Beta testing, it will minimize the failure risks. That is, the software will not fail. Now, it is the last test before the good or before the product is shipped to the customer, before it is delivered to the customer. Now, one of the major advantage of the beta testing is that it will provide the customer's feedback, and based upon the customer's feedback, the software is corrected or modified and then released to the customer. Now, in simple words, the alpha testing is done by the testing team, or you can say the developer, whereas the beta testing is done by the actual user and stakeholders.